Okay, guys, what we want to take a look at is we want to start with a point, and this point is 2, -3. First thing we want to talk about is our traditional way of representing coordinates or points is using this XY notation. And I just want to mention that we talked about this in this example over here in class. We can represent that in a couple different ways. We can represent points. So we can represent it in the traditional XY way, or we can represent it as G of 2 equals 5, for instance. And put more generally, that representation would be X as the input, and f of x or g of x or whatever function you're talking about as the output. All right, so we can represent this in a couple different ways. Okay, so let's take a look at this. Let's go ahead and plot our point. That's at 2, 1, 2 in the x direction, -3 in the y direction. There's my point. I want that point to be blue. So there's my point 2, 3. So what we want to look at is how can we move this point around? How can we change this point and manipulate this point? And when we do, what happens to the coordinates on this thing? All right, so the first thing we're going to look at are what we call translations. And really all a translation is a shift. It's a shift up and down or left and right. Okay? So you're kind of sliding that thing around this coordinate plane, up and down or left and right. So let's take a look at the first one. Let's look at how do we shift this point up and down. So if I want to take this point and I want to shift it, let's say up 1, 2, 3, 4. All right, so shifting this point up 4 units. So first thing is our new point is now has a coordinate at now has coordinates of 2, 1. All right, and our old point had coordinates, just so you get the visual here, of 2, -3. So what did I have to do to this particular thing in order to shift this up 4 units? Well, in order to shift this up 4 units, I actually had to add 4 to the y coordinate. So a couple different ways that you might represent this. Number one, you might see this written as, I'm going to take my original ordered pair, in this case it was 2, 3, and I'm going to change it into, I didn't do anything to the x. Notice that the x didn't change. What I did do to the y was I took my y and just added 4 to it in order to shift it up 4 units. Okay? So that's one notation. Another notation, and this is the notation that we're actually going to use most of the time, is instead of using y, we're actually going to use the f of x notation. So what did we do in order to shift this thing? Well, we took the output, or the y, and we just added 4 to it. So really this is just y plus 4 given in a different way, and this is how we want to represent this. We took the f of x, we took the function, in this case it's just an ordered pair, and we took the output and we shifted it up 4 units. Okay? So that's example number 1. If you want to shift it up, you can add 4. Example number 2 is just a shift down. So we want to shift this point down. Maybe I should use a different color. Let's go down 5 units. Alright, so I switched colors on you there so that we can kind of keep things color-coded, hopefully keep things a little bit more organized. But we're on this example, we want to shift this thing down 5 units. So take this original point, remember 2, -3 is our original, and we're going to go down 5 units. So 1, 2, 3, 4, 5. The new coordinates, we stayed at 2. And our new coordinates are now down at -1, 2, 3, 4, 5, 6, 7, 8. So again, very simply, in order to shift something down 5 units, we can either write it in this notation. We took our original coordinates, didn't change the x, but change the y. Or for our purposes, we want to focus on this this use here, or this notation here. We took our output, and we shift, in order to shift it down 5 units, we just subtract 5. Okay, so the next translation we want to look at is, we want to look at how do I shift or translate this particular point to -3. How do I shift that left and right? So in order to shift it left and right, let's start with shifting it. Let's go to the right. Let's go 6 units to the right. So graphically, we're going to come up here. Here's our original point. We're going to shift to -3. 1, 2, 3, 4, 5, 6. That's what it looks like. Here's my new point. It is at 1, 2, 3, 4, 5, 6, 7, 8 in the x direction, and -3 in the y. So notice this time your x changes. So this is at 8, -3, and your y actually stays the same. So in order to do this, this one's actually a little bit funky. Notice again, we want to change the x coordinate, and that's fine. That's easy enough to understand. But in order to do this, we actually have to take the x and do the opposite of what we think. So in this case, we have to add 6 to the x. But in our notation, we actually have to subtract 6. So we take f of x, and instead of f of x, we have an x minus 6 in our notation. This is how we shift right 6 units, and this is really the one that you got to be careful of. So this is actually opposite of what you think it is. So we're changing the x, that makes sense, but it's actually opposite of what we think our shift is going to be. Last example here. Last example here is we're going to shift that point to -3 to the left. And let's just go 3 units to the left. Graphically, it looks like this. 1, 2, 3. Stays on that same y plane there. But the x is going to change. And so in order to do this algebraically, we're going to take f of x, and we're going left. And remember, this rule tells us we got to actually do the opposite of what we think if we're going 3 units. So f of x plus 3 is going to shift this thing left 3 units. And I'll show you here in a minute why that is the way that it is.